In the linked list module, we saw how a linked list is a series of nodes linked together into a chain. We can use this type of structure to help build our stack. The stack would contain a linked list whose head node pointed to the most recently added, or top item. When an item was pushed onto the stack, in this case the number 1, the head pointer now points to this new node. This is the top node. When another value is pushed onto the stack, it is added to the front of the list and becomes the new top. This can repeat over and over. Eventually, the stack owner will need to remove data, and will do so by calling the pop method. When this happens, the front node of the list is removed, and the next node of the node chain becomes the top of the stack. So why would I choose to use a linked list as the data storage medium for a stack, as opposed to another structure such as an array? Well, first, because it's a linked list, it has no hard size limit. The only real constraint is the number of nodes that can be allocated, and for modern personal computers this would be a huge number, millions or billions of nodes. It's also a very straightforward way to implement a stack. An array, for example, would require bounds checking to make sure that a push didn't cause the item to exceed the array's bounds. But there are downsides to this approach, and many of them have to do with performance and scalability. The first is that adding an item to the stack causes a memory allocation to occur every time. This can end up causing undesirable performance characteristics in high-performance systems. On a related issue, the memory cost for each node can be significantly more than the cost of the data being stored. For example, a 32-bit value such as an integer might have memory overhead several times larger than the integer itself. And then there's the bucket of general performance issues. These issues really only affect high-performance systems, but they can be very significant. They include things like data locality problems and memory fragmentation, things that linked lists run into because they're storing the nodes throughout the heap, but an array can avoid by keeping all the data really near each other. These issues are really beyond the scope of this module, but there's a lot of information about these topics online and in books, so I'd encourage you to take a look if it's something you have an interest in.